Hi everyone, my name is Kaushik and today I'm trying to solve the Julia Leitford challenge problem. The problem is out of boundary path. So basically there is an grid has been given and there the position of the ball, football has been where it is currently the situated. That's the position also given, the position of the row and the column, and the maximum move also given. At max you will have to move the football, you can change that position. So after that changes position, how many ways the ball can go outside the grid, that means the out of the boundary path. So basically there is an all the procedure, all the type of possibility we can have to make. So first I am trying to dry run on this, how I am trying to solve this problem, and then after that I am trying to implement my logic as a coding interpretation. So first of all, what is that? First of all, if I have been trying to submit there, that one. So suppose the football is present right now. So maximum move is 3. So I can go there from that one. That is the one way. That is the one way. That is the one way. And that another way, that is also that one, and that one, that one, and that one. That's another way. That one, another one, and if I've been doing 2, 1, 2, 1, 2, 3, that's not going to outside. That is not possible. 1, 2, 3, that is not possible. So that's the logic basically. So that basically what is changing every step? What is changing every step? So if I have been doing there, there's the location that I and J is all time and been changing each and every position, and after changing that I and J coordinate, I mean that the changing of the coordinate position of the ball, at that time we also have count in account that how much move is remaining to go outside. So that will have to all time making there. So basically what is that? If I have been taking that I, J and the N, M, all the variable, and the max move, so every time what is that? The basic condition is that I plus 1 J, I minus 1 J, and I J minus 1, I J, J plus 1. So basically the I plus 1, that is goes to down, that is goes to upper, and that is goes to J minus 1, that is left, and that is goes to right. And after that, and when is max is less than 0, that is not possible. So in that case it will return 0. And otherwise, if I is equals to n, I mean that, yes, that is m, n, I is equals to n, and J is equals to m. If I have been taking that as an n cross m matrix, in that condition I is equals to n, J is equals to m, and that's the going to the outside, that's condition. And if I am going to the left condition value, so in that case, that is that one, or the I is equals to minus 1 and the J is equals to minus 1. In that case, that is goes to outside. In that case, I will return 1 basically. Why 1? Because that is the condition where I can found the path where that's the way the ball can go outside the grid. So basically what is the 3 variable, that is the changing coordinate, that is I, J, and the maximum moves remaining, that is max move. So what is that maximum space or time complexity it may happen? That means that I am traversing n, I is equals to n, m, and the maximum moves, max moves. So that is the order of time, I mean that is the time complexity, as well as that is the recursive calling I make there. But to remove the multiple time of same value visiting, so I am rightly memorizing that value. So that's why I have to make an the extra space of n cross m and extra space variable. That means that matrix. That means that is that type of matrix. That means the order of n, m, and max size matrix will have to require. So the space complexity is required up to that one. That's both the time complexity and the space complexity are the same for here. So right now I am trying to implement my logic as a coding interpretation. Yeah. Okay, that's the m cross n. So I implemented as a n cross m. So that is not a difficult one. That's I for that case here I is equals to m and the j is equals to n will have to taken care of. So first of all I have to take the n, not the n. Yeah, that is what I'll take that. What I'll take that is x. X is equals to. Okay, that is not required. That is not required because in m cross n that is been given. So I can directly call that solve value or the recursive function basically. So what is that the variable basically? The variable is basically ijnm. Okay. So ij, what is the value? That is the starting value. What is present right now? Row, start, column, that one. Then m cross m, that n, and yeah, that one, and the maximum move, and the max move, that one. So after that we'll have to make that the solve value, that one, integer ij, integer j, integer m, integer n, and integer max move. So after that we'll check that if max move is less than 0, in that case I will directly return 0. Otherwise case if two condition there, I is equals to m and j is equals to n, or the I is equals to -1 and the j is equals to -1. In that condition the return is equals to 1. And after that I will call that the value is basically okay. Yeah, so the left is basically solve of I j -1 m n max move -1. After that integer right is equals to solve I j plus 1 m comma n, the max move -1. Integer upper solve I -1 j m comma n max move -1. And after that down is equals to solve I plus 1 j m comma n max move -1. And after that integer total. So why I am taking this total? Because I'll have to make that the what is the question? Yeah, since the answer is very large and the number of paths to move ball out of the grid bundle, it can possible that left side, it can possible right side, it can possible downside, it can possible upper side. So that's why I am taking all the value into as a summation value. That means left, right plus upper plus down, and then after that I'll have first have to check that is it okay or not as a recursive call. Then after that I make the memorization. Yeah, it gave me a wrong answer. Okay. Yeah, what I make wrong. Okay. Yeah. Dot is equals to 0. Okay, that is the condition I'm wrong there. Hold on. Because at any of this condition is taking there, so that is the out of set. So there will be no required that for both condition of ij coordinate have to be the going outside for there. So basically that's the or value has to be placed there. So let me check that is it okay or not. Ij in or ij minus 1. Okay, I is equals to okay. Yeah, my recursive function has been right here, but if I've been putting that code to as a submit, that will be called as that time limit exit. So in that condition I'll have to make that the vector of I am right now memorization technique have been implemented through there. Vector of vector integer dp, and then after that first of all in there the dp of resize the m plus 1 vector in a vector n plus 1 vector of integer max move plus 1. So right now here that if dp of I j and max move not equals to minus 1. Okay, yeah, forgot the minus 1. Minus 1, that means that I already found that value. So in that case I will directly return the dp of I j max move, and that will have to put insert there after that dp of I j and max move is equals to total. So let me check that if I'm wrong or not. Yeah, it's giving me right answer. So okay, hold on, I forgot that too. Forgot to mention that define md 1 3 6 7 8. So after that I will mod that value. First here, because it may happen that here the integer overflow may happen. So let me check that if I am wrong or not. To check that I'll have to put that all the as a submit. So let me check. Yeah, it's giving me runtime error. Okay. Okay. Hold on. I'm taking that as all along basically. So let me check that after putting that all the value as in test case. I'm wrong or not. Yeah, it is accepting. I'm trying to submit my code twice. Yeah, it's got accepted. Thank you so much.